This is your lecture for Chapter 12. This chapter is all about acids and bases and how to deal with those and do calculations with those and what they are and all sorts of things. So one of the first things that we're going to talk about is how do we define acids and bases. So the first definition that there is to talk about is called the Arrhenius definition. And the Arrhenius definition is that acids produce H plus ions in water. Okay, so if we have a generic acid, and remember that acids usually almost always start with a hydrogen, okay, usually right out in front. And so hydrogens, and this should be an arrow right here, acids come apart to produce hydrogens in water. So an example here, we've got HCl, and you can recognize that it starts with an H, so it's going to be an acid. Comes apart into hydrogen ions and chlorine ions when it's in water. And then the Arrhenius definition for bases is that they produce OH minus in water. So usually we'll have some sort of metal with a hydroxide coming apart to make a metal and a hydroxide. Okay? And bases almost always are recognizable because they have that OH in them. Okay? There's only a couple of exceptions to that. Now, a better definition is called the Bronsted-Lowry definition. And the reason that I say that it's a better definition is because not all acids and bases behave quite the same way. So sometimes something can produce, can be an acid or a base, but it doesn't look like it's an acid or base. Okay, so a Bronsted-Lowry definition is that acids donate H plus ions and bases accept H plus ions. Okay, so the trick to this is follow something through an equation. Okay, so if we look at our first equation here with the HCl and the H2O, who loses a proton and who gains a proton? And when we talk about protons, we're talking about these H pluses. Okay, because a hydrogen ion with no electrons is an H plus, and if you take away a hydrogen's electron, what you're left with is a proton, and that's all it is. Okay, so when we talk about protons, that's what we're talking about. Okay, so looking at our first equation with the HCl, who loses a proton and who gains a proton? So if we look through, if we find the HCl on the other side, okay, the HCl has lost a proton. Don't do that. Silly thing. If the HCl loses a proton, that means that it's the acid. Okay? So HCl becomes Cl minus, that means that it's lost a proton. And if we look, H2O becomes H3O right here. Okay? And if it goes from H2O to H3O, it has accepted a proton, and that makes it a base. Okay, so let's look at the second example. So HCl, we find the Cl on the other side of the equation, and that one has lost a proton, so that makes it the acid. And then H3N really is NH3. That's the way we would normally see that. And then on the other side, it's NH4+. Okay, NH3 becomes NH4. So it has gained a proton, it's accepted a proton, so that makes it the base. So the trick is follow something through the equation. What does something become from left to right? Okay? So as a summary, with the Arrhenius definition produces H plus or H3O plus in water, and bases produce OH minus in water. And the Bronsted-Lowry definition is that the words are not coming out, that acids are H plus donors and bases are H plus acceptors. Okay? Usually these definitions will overlap. Right? So let's take a look at how do we look at these things in terms of equations. All right, so if we don't include water, if we're just looking at this HClO4, which is perchloric acid, what does it come apart as in water? So notice that it starts with an H+. Okay, so on the right-hand side, I'm going to show how it comes apart into its ions. And it'll come apart into an H+ aqueous and a ClO4- aqueous. Okay, now when I add water into the equation, what happens is that H+ goes to the water. Okay, so the only thing that's different is instead of H+, now I'll have H3O+. And I'll still have my ClO4-. Okay, now just to be clear, this H3O+ it has a name, and it's called a hydronium ion. Hydronium ion. Okay, and when we're talking about acids, we will use H+ and H3O+ interchangeably a lot of the time. Okay, they mean the same thing. All right, so let's do a little practice here. Now what we want to do is let's find that Br- on the other side of the equation. Okay, so if we look, the only thing that has a Br- is right here, and this is the same thing as Na+ and Br-. Okay, so that Br- has lost a proton, right? So that Br-, we're gonna sort of focus in on it, okay? And it's lost a proton, so that means that there's my acid, okay? And then I'm gonna take a look and I'm gonna focus on the anion again. That's usually a good way to go. If you focus on your anions and find them on the other side, what I'm gonna find is that OH picked up a proton to make H2O, making the NaOH the base. Okay. And on one hand, we can recognize these as acids and bases because my acid, that starts with an H, and my base has an OH in it. Okay, but it's not always foolproof. So let's look at equation B here, and let's see. Find NH3 on the other side and see what it has become. So NH3 right here has become NH4. So it has one more proton. It's picked up a proton, NH3 to NH4, so that makes this one my acid. Whoops, sorry, that's backwards. That makes it my base. My bad. The proton acceptor is the base. Okay, and then let's find this guy on the other side, and it's gone from H2S to a single HS-. So it's given up a proton. It has one fewer protons than it did before, so that makes it the acid. Okay. So our next equation, HNO2. Let's find that NO2 on the other side. HNO2 just becomes NO2-, so it has donated a proton, so that makes it my acid. And H2O has become H3O. It's picked up a proton, it's accepted a proton, so that makes it our base. Okay. So here are our acids. Our acids are in red, and then our bases are in green. All right. So this question says an aqueous solution of hypochlorous acid, HClO, contains which two dissolved ions? So the easiest thing to do is just write an equation for this, just like we did in the earlier slide. So HClO, aqueous, is going to come apart into an H+, aqueous, and a ClO-, aqueous. Okay, so that's pretty straightforward and easy, but it does say that it's an aqueous solution. So let's rewrite this. I'm going to rewrite it above here and include water in this situation. Okay, so remember my H+ here is going to latch on to my water. So in the products, I'm going to have H3O plus and my ClO minus. All right, so that's going to be our answer A here. In the reaction below, let's see what is what. So let's identify some things here. So let's find our H2O on the other side. So H2O has become H3O, so it's picked up a proton. So it has one more hydrogen than it did before. So if it's accepted a proton, that makes it a base. And our HCl, let's find it on the other side. HCl has become Cl minus. So that makes it our acid, right? It has lost a proton. It has one fewer protons than it did before. So H2O, answer A is H2O is the acid. Nope. B, H2O is the base, and HCl is the acid. H2O and HCl are both acids. Nope. And they're both bases. Nope.